Hello and welcome to my YouTube channel, and welcome back you problem-solving aficionados. Today I have got another challenging math problems to put your skills to the test. So if you're ready to stretch your mind a little bit and push your limits, then this video is for you. Let's get started. What do we have? As a condition, we have x plus 1 over x equals 2 cosine of alpha. And the problem wants us to find x to the power of n plus 1 over x to the power of n. How can we solve this problem? So if I check the condition, I have, I have x plus 1 over x. Clearly, x is not 0 because it cannot be. It's in the denominator. So I can confidently multiply both sides of this condition here by x. So what do we get? We get x2. If I bring the term on the right to the left, then I have x2 minus 2 cosine of alpha x plus 1 equals 0. And if I find the roots of this equation, then I get x equals cosine of alpha plus minus square root of 1, or sorry, I think it is cosine 2 of alpha minus 1. But we know from trigonometry that this is equal to minus sine 2 of alpha. So the square root of sine 2 of alpha is obvious, it's sine of alpha. And the problem is with that minus. And that we know from complex number theory that the square root of minus 1 is basically I. We define it as I. So here I get cosine of alpha plus minus I sine of alpha. Beautiful, but that is a famous identity in complex analysis. So we know that the Euler formula is the following: e to the power of I alpha equals cosine of alpha plus I sine of alpha. And if alpha is negative, the only thing which changes is this term, because cosine of minus alpha is basically cosine of alpha. So I can say that x equals to e to the power of minus or plus minus I alpha. That is x, guys. So if x is that, then what is x to the power of n plus 1 over x to the power of n? That's very easy to calculate. So x to the power of n here is basically this to the power of n, and that is nothing but e to the power of plus minus I n alpha. So as a result, I get x to the power of n plus 1 over x to the power of n equals e to the power of plus minus I n alpha plus 1 over e plus minus I n alpha. But we know we can bring this to the numerator, and then I get e to the power of plus minus I n alpha. But when I get this guy here to the denominator, the power of it will be multiplied by minus 1. So instead of plus minus, I get minus plus. So here I have e to the power of minus plus I n alpha. It means minus here corresponds to plus, and plus corresponds to minus. So therefore, that expression is, if I just again use the Euler expansion, I get cosine of n alpha plus minus I sine of n alpha. And for the second one, I get plus cosine of n alpha minus plus, this is very important, I sine of n alpha. So in other words, if you look at this term and you look at this term, plus cancels out minus, and minus I sine of n alpha cancels out plus I sine of n alpha. Therefore, I get x to the power of n plus 1 over x to the power of n equals 2 cosine of n alpha. And that's how you solve this problem. I hope you found this video both informative and enjoyable. If you did, please consider giving this video a like and subscribing to my channel for more math problem solving videos like this one. By liking this video, you help support my channel and encourage me to make more content like this. And by subscribing, you'll be the first one to know when I upload new videos, so you won't miss out on any of the math problem solving fun. Thanks for watching, and I'll see you in the next video.